Hello everyone, welcome back again to the course Comprehensive Slope Stability Analysis using PLAXIS 2D. This is tutorial 13, Mesh Quality and Sensitivity in Slope Stability Analysis using PLAXIS 2D. So in this lecture we will talk and explain about mesh quality and mesh sensitivity and how it affected the results of slope stability using PLAXIS 2D. So in this lecture we will understand the role of mesh in slope stability analysis, and also we will compare the difference between different types of mesh size available in PLAXIS 2D, which are very coarse mesh, coarse, medium, fine, and very fine mesh. Also, we will see how the mesh size affected the factor of safety and deformation, and also we will assess talk about how can we estimate or assess the quality of the mesh and its performance for reliable analysis in PLAXIS 2D. So in here we have, as we know, we have two different triangular elements in PLAXIS 2D. We have a 6-noded element or 15-noded element, and in this element, for example, in a 6-noded triangular element, we have 6 nodes for displacement, and also 3 points that's used for stress calculation. Also in a 15-noded triangular element, we have 15 nodes, and we also have 12 stress points. So what is the mesh? The mesh is a subdivision of geometry into a finer element or finite element, and the accuracy of the results depend on element size and mesh refinement. For example, when we have a very coarse mesh, maybe the results are not very accurate. Also, when we use a very fine mesh, maybe also the results are not very realistic. That's why the mesh quality and mesh sensitivity is very important in slope stability analysis, and also in all geotechnical problems. So coarse mesh, it is faster for calculation but less accuracy, and finer mesh more accurate but maybe it take a higher computational time. So in PLAXIS we have these 5 types of mesh: very coarse mesh, and medium mesh, and fine mesh, and very fine mesh. So in a very fine mesh, maybe the accuracy is high, but it also takes a very high computation time. Actually, this high computational time is correct when we have a very complex geotechnical problem or very complex slope geometry with very fine mesh or structures, etc. So it will not take a very high computational time when we have a simple geometry or 1, 2, 3 layers of soil stratigraphy. Also, in addition to these 5 different types of mesh, PLAXIS allows us to make a refinement for a specific region at the problem. For example, when we have a slope, maybe we can do refinement at the expected failure zone or a near structural element for more accuracy. So I will open the tutorial number 9, slope stability analysis using the hardening soil model. This is tutorial number 9, slope stability analysis using hardening soil model. Because I will do some changes in this tutorial, that's why I will save this lesson under under the title of lesson 13. So I will copy the title, and in here we will click on File, Save Project As, and I will paste the new title in here and click OK. So we proceed to Mesh, and I will delete the coarseness factor because I want to do a mesh sensitivity analysis for this problem. For example, we can see different types of mesh in here. We have a very coarse mesh. As you can see, the number of elements are less, and in here we have a medium mesh. Number of elements is increased. Also in here it's a very fine mesh. In PLAXIS 2D we can see the number of elements is very much compared to these two mesh. And also in here we have a fine mesh, but we have done some refinement at the expected failure surface of the slope and at the region where the surcharge load is applied. So for example, we can see from poor to good quality, or from good quality to poor quality. For example, in here we can see all of them are greater than 0.5, and we can still accept this mesh quality and rely on the analysis. But if you have a lot of element that has the mesh quality maybe 0.5 or less than 0.5, we should adjust the mesh quality to get the high quality mesh.